Section 37 of Theory of Colours. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Theory of Colours by Johann Wolfgang von Goethe, translated by Charles Eastlake. Section 37. Part 5. Relation to other pursuits. Relation to philosophy. 716. The investigator of nature cannot be required to be a philosopher, but it is expected that he should so far have attained the habit of philosophizing as to distinguish himself essentially from the world, in order to associate himself with it again in a higher sense. He should form to himself a method in accordance with observation, but he should take heed not to reduce observation to mere notion, to substitute words for this notion, and to use and deal with these words as if they were things. He should be acquainted with the labours of philosophers in order to follow up the phenomena which have been the subject of his observation into the philosophic region. 717. It cannot be required that the philosopher should be a naturalist, and yet his cooperation in physical researches is as necessary as it is desirable. He needs not an acquaintance with details for this, but only a clear view of those conclusions where insulated facts meet. 718. We have before, number 175, alluded to this important consideration, and repeat it here where it is in its place. The worst that can happen to physical science, as well as to many other kinds of knowledge, is that men should treat a secondary phenomenon as a primordial one, and, since it is impossible to derive the original fact from the secondary state, seek to explain what is in reality the cause by an effect made to usurp its place. Hence arises an endless confusion, a mere verbiage, a constant endeavour to seek and to find subterfuges whenever truth presents itself and threatens to be overpowering. 719. While the observer, the investigator of nature, is thus dissatisfied in finding that the appearances he sees still contradict a received theory, the philosopher can calmly continue to operate in his abstract department on a false result, for no result is so false but that it can be made to appear valid, as form without substance by some means or other. 720. If, on the other hand, the investigator of nature can attain to the knowledge of that which we have called a primordial phenomenon, he is safe, and the philosopher with him. The investigator of nature is safe, since he is persuaded that he has here arrived at the limits of his science, that he finds himself at the height of experimental research, a height whence he can look back upon the details of observation in all its steps, and forwards into, if he cannot enter, the regions of theory. The philosopher is safe, for he receives from the experimentalist an ultimate fact, which in his hands now becomes an elementary one. He now justly pays little attention to appearances which are understood to be secondary, whether he already finds them scientifically arranged, or whether they present themselves to his causal observation scattered and confused. Should he even be inclined to go over this experimental ground himself, and not be averse to examination in detail, he does this conveniently, instead of lingering too long in the consideration of secondary and intermediate circumstances, or hastily passing them over without becoming accurately acquainted with them. 721. To place the doctrine of colours nearer, in this sense, within the philosopher's reach, was the author's wish, and although the execution of his purpose, from various causes, does not correspond with his intention, he will still keep this object in view in an intended recapitulation, as well as in the polemical and historical portions of his work, for he will have to return to the consideration of this point hereafter, on an occasion where it will be necessary to speak with less reserve. Relation to mathematics. 722. It may be expected that the investigator of nature, who proposes to treat the science of natural philosophy in its entire range, should be a mathematician. In the Middle Ages, mathematics was the chief organ by means of which men hoped to master the secrets of nature, and even now, geometry in certain departments of physics is justly considered of first importance. The author can boast of no attainments of this kind, and on this account confines himself to departments of science which are independent of geometry, departments which in modern times have been opened up far and wide. 724. It will be universally allowed that mathematics, one of the noblest auxiliaries which can be employed by man, has, in one point of view, been of the greatest use to the physical sciences, but that, by a false application of its methods, it has in many respects been prejudicial to them, is also not to be denied. We find it here and there reluctantly admitted. 725. The theory of colours in particular has suffered much, and its progress has been incalculably retarded by having been mixed up with optics generally, a science which cannot dispense with mathematics, whereas the theory of colours, in strictness, may be investigated quite independently of optics. 726. But besides this, there was an additional evil. A great mathematician was possessed with an entirely false notion on the physical origin of colours, yet, owing to his great authority as a geometer, the mistakes which he committed as an experimentalist long became sanctioned in the eyes of a world ever fettered in prejudices. 727. The author of the present inquiry has endeavoured throughout to keep the theory of colours distinct from the mathematics, although there are evidently certain points where the assistance of geometry would be desirable. Had not the unprejudiced mathematicians with whom he has had, or still has, the good fortune to be acquainted, been prevented by other occupations from making common cause with him, his work would not have wanted some merit in this respect. But this very want may be in the end advantageous, since it may now become the object of the enlightened mathematician to ascertain where the doctrine of colours is in need of his aid, and how he can contribute the means at his command with a view to the complete elucidation of this branch of physics. 728. In general, it were to be wished that the Germans, who render such good service to science, while they adopt all that is good from other nations, could by degrees accustom themselves to work in concert. We live, it must be confessed, in an age the habits of which are directly opposed to such a wish. Every one seeks not only to be original in his views, but to be independent of the labours of others, or at least to persuade himself that he is so, even in the course of his life and occupation. It is very often remarked that men who undoubtedly have accomplished much quote themselves only, their own writings, journals, and compendiums, whereas it would be far more advantageous for the individual and for the world if many were devoted to a common pursuit. The conduct of our neighbours, the French, is, in this respect, worthy of imitation. We have a pleasing instance in Cuvier's preface to his Tableau élémentaire de l'histoire naturelle des animaux. 729. He who has observed science and its progress with an unprejudiced eye might even ask whether it is desirable that so many occupations and aims, though allied to each other, should be united in one person, and whether it would not be more suitable for the limited powers of the human mind to distinguish, for example, the investigator and inventor from him who employs and applies the result of experiment. Astronomers, who devote themselves to the observation of the heavens and the discovery or enumeration of stars, have in modern times formed, to a certain extent, a distinct class from those who calculate the orbits, consider the universe in its connection, and more accurately define its laws. The history of the doctrine of colours will often lead us back to these considerations. Relation to the technical operations of the dyer. 730. If in our labours we have gone out of the province of the mathematician, we have, on the other hand, endeavoured to meet the practical views of the dyer, and although the chapter which treats of colour in a chemical point of view is not the most complete and circumstantial, yet in that portion, as well as in our general observations respecting colour, the dyer will find his views assisted far more than by the theory hitherto in vogue, which failed to afford him any assistance. 731. It is curious, in this view, to take a glance at the works containing directions on the art of dyeing. As the Catholic, on entering his temple, sprinkles himself with holy water, and after bending the knee proceeds perhaps to converse with his friends on his affairs, without any especial devotion, so all the treatises on dyeing begin with a respectful allusion to the accredited theory, without afterwards exhibiting a single trace of any principle deduced from this theory, or showing that it has thrown light on any part of the art, or that it offers any useful hints in furtherance of practical methods. 732. On the other hand, there are men who, after having become thoroughly and experimentally acquainted with the nature of dyes, have not been able to reconcile their observations with the received theory, who have, in short, discovered its weak points, and sought for a general view more consonant to nature and experience. When we come to the names of Castell and Gulich in our historical review, we shall have occasion to enter into this more fully, and an opportunity will then present itself to show that an assiduous experience in taking advantage of every accident may, in fact, be said almost to exhaust the knowledge of the province to which it is confined. The high and complete result is then submitted to the theorist, who, if he examines facts with accuracy and reasons with candour, will find such materials eminently useful as a basis for his conclusions. Relation to physiology and pathology. 733. If the phenomena adduced in the chapter where colours were considered in a physiological and pathological view are for the most part generally known, still some new views, mixed up with them, will not be unacceptable to the physiologist. We especially hope to have given him cause to be satisfied by classing certain phenomena which stood alone, under analogous facts, and thus, in some measure, to have prepared the way for his further investigations. 734. The appendix on pathological colours, again, is admitted to be scanty and unconnected. We reflect, however, that Germany can boast of men who are not only highly experienced in this department, but are likewise so distinguished for general cultivation, that it can cost them but little to revise this portion, to complete what has been sketched, and at the same time to connect it with the higher facts of organisation. Relation to natural history. 735. If we may at all hope that natural history will gradually be modified by the principle of deducing the ordinary appearances of nature from higher phenomena, the author believes he may have given some hints and introductory views bearing on this object also. As colour, in its infinite variety, exhibits itself on the surface of living beings, it becomes an important part of the outward indications, by means of which we can discover what passes underneath. 736. In one point of view it is certainly not to be too much relied on account of its indefinite and mutable nature. Yet even this mutability, inasmuch as it exhibits itself as a constant quality, again becomes a criterion of mutable vitality, and the author wishes nothing more than that time may be granted him to develop the results of his observations on this subject more fully. Here they would not be in their place. Relation to general physics. 737. The state in which general physics now is, appears, again, particularly favourable to our labours. For natural philosophy, owing to indefatigable and variously directed research, has generally attained such eminence that it appears not impossible to refer a boundless empiricism to one centre. 738. Without referring to subjects which are too far removed from our own province, we observe that the formulae under which the elementary appearances of nature are expressed altogether tend in this direction, and it is easy to see that through this correspondence of expression a correspondence in meaning will necessarily be soon arrived at. 739. True observers of nature, however they may differ in opinion in other respects, will agree that all which presents itself as appearance, all that we meet with as phenomenon, must either indicate an original division which is capable of union, or an original unity which admits of division, and that the phenomenon will present itself accordingly. To divide the united, to unite the divided, is the life of nature. This is the eternal systole and diastole, the eternal collapsion and expansion, the inspiration and expiration of the world in which we live and move. 740. It is hardly necessary to observe that what we here express as number and restrict to dualism is to be understood in a higher sense. The appearance of a fourth order of facts progressively developing themselves is to be similarly understood, but actual observation should, above all, be the basis of all these expressions. 741. Iron is known to us as a peculiar substance, different from other substances. In its ordinary state, we look upon it as a mere material remarkable only on account of its fitness for various uses and applications. How little, however, is necessary to do away with the comparative insignificancy of this substance. A twofold power is called forth, which, while it tends again to a state of union, and, as it were, seeks itself, acquires a kind of magical relation with its like, and propagates this double property, which is in fact but a principle of reunion throughout all bodies of the same kind. We here first observe the mere substance, iron. We see the division that takes place in it propagate itself and disappear, and again easily become re-excited. This, according to our mode of thinking, is a primordial phenomenon in immanent relation with its idea, and which acknowledges nothing earthly beyond it. 742. Electricity is again peculiarly characterized. As a mere quality we are unacquainted with it. For us it is nothing, a zero, a mere point, which, however, dwells in all apparent existences, and at the same time is the point of origin whence, on the slightest stimulus, a double appearance presents itself, an appearance which only manifests itself to vanish. The conditions under which this manifestation is excited are infinitely varied, according to the nature of particular bodies. From the rudest mechanical friction of very different substances with one another, to the mere contiguity of two entirely similar bodies, the phenomenon is present and stirring, nay, striking and powerful, and so decided and specific, that when we employ the terms or formulae polarity, plus and minus, for north and south, for glass and resin, we do so justifiably and in conformity with nature. 743. This phenomenon, although it especially affects the surface, is yet by no means superficial. It influences the tendency or determination of material qualities, and connects itself in immediate cooperation with the important double phenomenon which takes place so universally in chemistry, oxidation and deoxidation. 744. To introduce and include the appearances of colour in this series, this circle of phenomena was the object of our labours. What we have not succeeded in, others will accomplish. We found a primordial vast contrast between light and darkness, which may be more generally expressed by light and its absence. We looked for the intermediate state and sought by means of it to compose the visible world of light, shade, and colour. In the prosecution of this we employed various terms applicable to the development of the phenomena, terms which we adopted from the theories of magnetism, of electricity, and of chemistry. It was necessary, however, to extend this terminology, since we found ourselves in an abstract region and had to express more complicated relations. 745. If electricity and galvanism, in their general character, are distinguished as superior to the more limited exhibition of magnetic phenomena, it may be said that colour, although coming under similar laws, is still superior, for since it addresses itself to the noble sense of vision, its perfections are more generally displayed. Compare the varied effects which result from the augmentation of yellow and blue to red, from the combination of these two higher extremes to pure red, and the union of the two inferior extremes to green. What a far more varied scheme is apparent here than that in which magnetism and electricity are comprehended. These last phenomena may be said to be inferior again on another account, for though they penetrate and give life to the universe, they cannot address themselves to man in a higher sense in order to his employing them aesthetically. The general, simple physical law must first be elevated and diversified itself in order to be available for elevated uses. 746. If the reader, in this spirit, recalls what has been stated by us throughout, generally and in detail, with regard to colour, he will himself pursue and unfold what has been here only lightly hinted at. He will augur well for science, technical processes, and art, if it should prove possible to rescue the attractive subject of the doctrine of colours from the atomic restriction and isolation in which it has been banished. In order to restore it to the general dynamic flow of life and action which the present age loves to recognise as nature, these considerations will press upon us more strongly when, in the historical portion, we shall have to speak of many an enterprising and intelligent man who failed to possess his contemporaries with his convictions. Relation to the theory of music. 747. Before we proceed to the moral associations of colour and the aesthetic influences arising from them, we have here to say a few words on its relation to melody. That a certain relation exists between the two has been always felt. This is proved by the frequent comparisons we meet with, sometimes as passing allusions, sometimes as circumstantial parallels. The error which writers have fallen into in trying to establish this analogy we would thus define. 748. Colour and sound do not admit of being directly compared together in any way, but both are referable to a higher formula, both are derivable, although each for itself, from this higher law. They are like two rivers which have their source in one and the same mountain, but subsequently pursue their way under totally different conditions, in two totally different regions, so that throughout the whole course of both no 2 points can be compared. Both are general, elementary effects, acting according to the general law of separation and tendency to union, of undulation and oscillation, yet acting thus in wholly different provinces, in different modes, on different elementary mediums, for different senses. 749. Could some investigator rightly adopt the method in which we have connected the doctrine of colours with natural philosophy generally, and happily supply what has escaped or been missed by us? The theory of sound, we are persuaded, might be perfectly connected with general physics. At present it stands, as it were, isolated within the circle of science. 750. It is true it would be an undertaking of the greatest difficulty to do away with the positive character which we are now accustomed to attribute to music, a character resulting from the achievements of practical skill, from accidental, mathematical, aesthetical influences, and to substitute for all this a merely physical inquiry tending to resolve the science into its first elements. Yet, considering the point at which science and art are now arrived, considering the many excellent preparatory investigations that have been made relative to this subject, we may, perhaps, still see it accomplished. Concluding observations on terminology. 751. We never sufficiently reflect that a language, strictly speaking, can only be symbolical and figurative, that it can never express things directly, but only, as it were, reflectedly. This is especially the case in speaking of qualities which are only imperfectly presented to observation, which might rather be called powers than objects, and which are ever in movement throughout nature. They are not to be arrested, and yet we find it necessary to describe them. Hence we look for all kinds of formulae in order, figuratively at least, to define them. 752. Metaphysical formulae have breadth as well as depth, but on this very account they require a corresponding import. The danger here is vagueness. Mathematical expressions may in many cases be very conveniently and happily employed, but there is always an inflexibility in them, and we presently feel their inadequacy, for even in elementary cases we are very soon conscious of an incommensurable idea. They are, besides, only intelligible to those who are especially conversant in the sciences to which such formulae are appropriated. The terms of the science of mechanics are more addressed to the ordinary mind, but they are ordinary in other senses, and always have something unpolished. They destroy the inward life to offer from without an insufficient substitute for it. The formulae of the corpuscular theories are nearly allied to the last. Through them the mutable becomes rigid, description and expression uncouth, while again moral terms, which undoubtedly can express nicer relations, have the effect of mere symbols in the end, and are in danger of being lost in a play of wit. 753. If, however, a writer could use all these modes of description and expression with perfect command, and thus give forth the results of his observations on the phenomena of nature in a diversified language, if he could preserve himself from predilections, still embodying a lively meaning in as animated an expression, we might look for much instruction communicated in the most agreeable of forms. 754. Yet how difficult it is to avoid substituting the sign for the thing! How difficult to keep the essential quality still living before us, and not to kill it with the word! With all this, we are exposed in modern times to a still greater danger by adopting expressions and terminologies from all branches of knowledge and science to embody our views of simple nature. Astronomy, cosmology, geology, natural history, nay, religion and mysticism, are called in aid, and how often do we not find a general idea in an elementary state rather hidden and obscured than elucidated and brought nearer to us by the employment of terms, the application of which is strictly specific and secondary. We are quite aware of the necessity which led to the introduction and general adoption of such a language. We also know that it has become in a certain sense indispensable, but it is only a moderate, unpretending recourse to it, with an internal conviction of its fitness, that can recommend it. 755. After all, the most desirable principle would be that writers should borrow the expressions employed to describe the details of a given province of investigation from the province itself, treating the simplest phenomenon as an elementary formula, and deriving and developing the more complicated designations from this. 756. The necessity and suitableness of such a conventional language where the elementary sign expresses the appearance itself has been duly appreciated by extending, for instance, the application of the term polarity, which is borrowed from the magnet to electricity, etc. The plus and minus, which may be substituted for this, have found as suitable an application to many phenomena. Even the musician, probably without troubling himself about these other departments, has been naturally led to express the leading difference in the modes of melody by major and minor. 757. For ourselves, we have long wished to introduce the term polarity into the doctrine of colours. With what right and in what sense the present work may show. Perhaps we may hereafter find room to connect the elementary phenomena together according to our mode, by a similar use of symbolic terms, terms which must at all times convey the directly corresponding idea. We shall thus render more explicit what has been here only alluded to generally, and perhaps too vaguely expressed. End of section 37.
Section 38 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Availle in May 2017. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 38. Part 6. Effect of color with reference to moral associations. 758. Since color occupies so important a place in the series of elementary phenomena, filling as it does the limited circle assigned to it with fullest variety, we shall not be surprised to find that its effects are at all times decided and significant, and that they are immediately associated with the emotions of the mind. We shall not be surprised to find that these appearances presented singly are specific, that in combination they may produce an harmonious, characteristic, often even an inharmonious effect on the eye, by means of which they act on the mind, producing this impression in their most general elementary character, without relation to the nature or form of the object on whose surface they are apparent. Hence, color considered as an element of art may be made subservient to the highest aesthetical ends. 759. People experience a great delight in color, generally. The eye requires it as much as it requires light. We have only to remember the refreshing sensation we experience, if on a cloudy day the sun illumines a single portion of the scene before us, and displays its colors. That healing powers were ascribed to colored gems may have arisen from the experience of this indefinable pleasure. 760. The colors which we see on objects are not qualities entirely strange to the eye. The organ is not thus merely habituated to the impression. No, it is always predisposed to produce color of itself, and experiences a sensation of delight if something analogous to its own nature is offered to it from without, if its susceptibility is distinctly determined towards a given state. 761. From some of our earlier observations we can conclude that general impressions produced by single colors cannot be changed, that they act specifically and must produce definite, specific states in the living organ. 762. They likewise produce a corresponding influence on the mind. Experience teaches us that particular colors excite particular states of feeling. It is related of a witty Frenchman, Il prétendoit que son ton de conversation avec madame ait changé depuis qu'elle avoit changé en cramoisi le meuble de son cabinet, qui était bleu. 763. In order to experience these influences completely, the eye should be entirely surrounded with one color. We should be in a room of one color, or look through a colored glass. We are then identified with the hue. It attunes the eye and mind in mere unison with itself. 764. The colors on the plus side are yellow, red-yellow, orange, yellow-red, minium, cinnabar. The feelings they excite are quick, lively, aspiring. Yellow. 765. This is the color nearest the light. It appears on the slightest mitigation of light, whether by semi-transparent mediums or faint reflection from white surfaces. In prismatic experiments it extends itself alone and widely in the light space, and while the two poles remain separated from each other, before it mixes with blue to produce green, it is to be seen in its utmost purity and beauty. How the chemical yellow develops itself in and upon the white has been circumstantially described in its proper place. 766. In its highest purity it always carries with it the nature of brightness, and has a serene, gay, softly exciting character. 767. In this state, applied to dress, hangings, carpeting, etc., it is agreeable. Gold in its perfectly unmixed state, especially when the effect of polish is superadded, gives us a new and high idea of this color. In like manner, a strong yellow, as it appears on satin, has a magnificent and noble effect. 768. We find from experience, again, that yellow excites a warm and agreeable impression. Hence, in painting, it belongs to the illumined and emphatic side. 769. This impression of warmth may be experienced in a very lively manner if we look at a landscape through a yellow glass, particularly on a grey winter's day. The eye is gladdened, the heart expanded and cheered, a glow seems at once to breathe towards us. 770. If, however, this color in its pure and bright state is agreeable and gladdening, and in its utmost power is serene and noble, it is, on the other hand, extremely liable to contamination, and produces a very disagreeable effect if it is sullied, or in some degree tends to the minus side. Thus the color of sulphur, which inclines to green, has a something unpleasant in it. 771. When a yellow color is communicated to dull and coarse surfaces, such as common cloth, felt, or the like, on which it does not appear with full energy, the disagreeable effect alluded to is apparent. By a slight and scarcely perceptible change, the beautiful impression of fire and gold is transformed into one not undeserving the epithet foul, and the color of honor and joy reversed to that of ignominy and aversion. To this impression the yellow hats of bankrupts and the yellow circles on the mantles of Jews may have owed their origin. Red-yellow. 772. As no color can be considered as stationary, so we can very easily augment yellow into reddish by condensing or darkening it. The color increases in energy and appears in red-yellow more powerful and splendid. 773. All that we have said of yellow is applicable here in a higher degree. The red-yellow gives an impression of warmth and gladness, since it represents the hue of the intenser glow of fire, and of the milder radiance of the setting sun. Hence it is agreeable around us, and again, as clothing, in greater or less degrees is cheerful and magnificent. A slight tendency to red immediately gives a new character to yellow, and while the English and Germans content themselves with bright pale yellow colors in leather, the French, as Castell has remarked, prefer a yellow enhanced to red. Indeed, in general, everything in color is agreeable to them which belongs to the active side. Yellow-red. 774. As pure yellow passes very easily to red-yellow, so the deepening of this last to yellow-red is not to be arrested. The agreeable, cheerful sensation which red-yellow excites increases to an intolerably powerful impression in bright yellow-red. 775. The active side is here in its highest energy, and it is not to be wondered at that impetuous, robust, uneducated men should be especially pleased with this color. Among savage nations the inclination for it has been universally remarked, and when children, left to themselves, begin to use tints, they never spare vermilion and minium. 776. In looking steadfastly at a perfectly yellow-red surface, the color seems actually to penetrate the organ. It produces an extreme excitement, and still acts thus when somewhat darkened. A yellow-red cloth disturbs and enrages animals. I have known men of education to whom its effect was intolerable if they chanced to see a person dressed in a scarlet cloak on a grey, cloudy day. 777. The colors on the minus side are blue, red-blue, and blue-red. They produce a restless, susceptible, anxious impression. Blue. 778. As yellow is always accompanied with light, so it may be said that blue still brings a principle of darkness with it. 779. This color has a peculiar and almost indescribable effect on the eye. As a hue it is powerful, but it is on the negative side, and in its highest purity is, as it were, a stimulating negation. Its appearance, then, is a kind of contradiction between excitement and repose. 780. As the upper sky and distant mountains appear blue, so a blue surface seems to retire from us. 781. But as we readily follow an agreeable object that flies from us, so we love to contemplate blue, not because it advances to us, but because it draws us after it. Blue gives us an impression of cold, and thus again reminds us of shade. We have before spoken of its affinity with black. 783. Rooms which are hung with pure blue appear in some degree larger, but at the same time empty and cold. 784. The appearance of objects seen through a blue glass is gloomy and melancholy. 785. When blue partakes in some degree of the plus side, the effect is not disagreeable. Sea green is rather a pleasing color. Red-blue. 786. We found yellow very soon tending to the intense state, and we observed the same progression in blue. 787. Blue deepens very mildly into red, and thus acquires a somewhat active character, although it is on the passive side. Its exciting power is, however, of a very different kind from that of red-yellow. It may be said to disturb rather than enliven. 788. As augmentation itself is not to be arrested, so we feel an inclination to follow the progress of the color, not, however, as in the case of the red-yellow, to see it still increase in the active sense, but to find a point to rest in. 789. In a very attenuated state, this color is known to us under the name of lilac, but even in this degree it has a something lively without gladness. 790. This unquiet feeling increases as the hue progresses, and it may be safely assumed that a carpet of a perfectly pure deep blue-red would be intolerable. On this account, when it is used for dress, ribbons, or other ornaments, it is employed in a very attenuated and light state, and thus displays its character as above defined, in a peculiarly attractive manner. 798. As the higher dignitaries of the Church have appropriated this unquiet color to themselves, we may venture to say that it unceasingly aspires to the cardinal's red through the restless degrees of a still impatient progression. Red. 792. We are here to forget everything that borders on yellow or blue. We are to imagine an absolutely pure red, like fine carmine suffered to dry on white porcelain. We have called this color purpur by way of distinction, although we are quite aware that the purple of the ancients inclined more to blue. 793. Whoever is acquainted with the prismatic origin of red will not think it paradoxical if we assert that this color partly actu, partly potentia, includes all the other colors. 794. We have remarked a constant progress or augmentation in yellow and blue, and seen what impressions were produced by the various states. Hence it may naturally be inferred that now, in the junction of the deepened extremes, a feeling of satisfaction must succeed, and thus, in physical phenomena, this highest of all appearances of color arises from the junction of two contrasted extremes which have gradually prepared themselves for a union. 795. As a pigment, on the other hand, it presents itself to us already formed, and is most perfect as a hue in cochineal, a substance which, however, by chemical action may be made to tend to the plus or the minus side, and may be considered to have attained the central point in the best carmine. 796. The effect of this color is as peculiar as its nature. It conveys an impression of gravity and dignity, and at the same time of grace and attractiveness. The first in its dark, deep state, the latter in its light attenuated tint, and thus the dignity of age and the amiableness of youth may adorn itself with degrees of the same hue. 797. History relates many instances of the jealousy of sovereigns with regard to the quality of red. Surrounding accompaniments of this color have always a grave and magnificent effect. 798. The red glass exhibits a bright landscape in so dreadful a hue as to inspire sentiments of awe. 799. Kermes and cochineal, the two materials chiefly employed in dyeing to produce this color, incline more or less to the plus or minus state, and may be made to pass and repass the culminating point by the action of acids and alkalis. It is to be observed that the French arrest their operations on the active side, as is proved by the French scarlet, which inclines to yellow. The Italians, on the other hand, remain on the passive side, for their scarlet has a tinge of blue. 800. By means of a similar alkaline treatment, the so-called crimson is produced, a color which the French must be particularly prejudiced against, since they employ the expressions sot en cramoisi, méchant en cramoisi, to mark the extreme of the silly and the reprehensible. Green. 801. If yellow and blue, which we consider as the most fundamental and simple colors, are united as they first appear, in the state of their action, the color which we will call green is the result. 802. The eye experiences a distinctly grateful impression from this color. If the two elementary colors are mixed in perfect equality, so that neither predominates, the eye and the mind repose on the result of this junction as upon a simple color. The beholder has neither the wish nor the power to imagine a state beyond it. Hence, for rooms to live in constantly, the green color is most generally selected. End of section 38. Section 39 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Availle in April 2017. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 39. Completeness and Harmony. 803. We have hitherto assumed, for the sake of clearer explanation, that the eye can be compelled to assimilate or identify itself with a single color, but this can only be possible for an instant. 804. For when we find ourselves surrounded by a given color which excites its corresponding sensation on the eye, and compels us by its presence to remain in a state identical with it, this state is soon found to be forced, and the organ unwillingly remains in it. 805. When the eye sees a color, it is immediately excited, and it is its nature, spontaneously and of necessity, at once to produce another, which with the original color comprehends the whole chromatic scale. A single color excites, by a specific sensation, the tendency to universality. 806. To experience this completeness, to satisfy itself, the eye seeks for a colorless space next every hue in order to produce the complemental hue upon it. 807. In this resides the fundamental law of all harmony of colors, of which every one may convince himself by making himself accurately acquainted with the experiments which we have described in the chapter on the physiological colors. 808. If, again, the entire scale is presented to the eye externally, the impression is gladdening, since the result of its own operation is presented to it in reality. We turn our attention, therefore, in the first place, to this harmonious juxtaposition. 809. As a very simple means of comprehending the principle of this, the reader has only to imagine a movable diametrical index in the colorific circle. The index, as it revolves round the whole circle, indicates at its two extremes the complemental colors, which, after all, may be reduced to three contrasts. 810. Yellow demands red-blue, blue demands red-yellow, red demands green, and contrariwise. 811. In proportion as one end of the supposed index deviates from the central intensity of the colors, arranged as they are in the natural order, so the opposite end changes its place in the contrasted gradation, and by such a simple contrivance the complemental colors may be indicated at any given point. A chromatic circle might be made for this purpose, not confined, like our own, to the leading colors, but exhibiting them with their transitions in an unbroken series. This would not be without its use, for we are here considering a very important point which deserves all our attention. 812. We before stated that the eye could be in some degree pathologically affected by being long confined to a single color; that, again, definite moral impressions were thus produced, at one time lively and aspiring, at another susceptible and anxious, now exalted to grand associations, now reduced to ordinary ones. We now observe that the demand for completeness, which is inherent in the organ, frees us from this restraint. The eye believes itself by producing the opposite of the single color forced upon it, and thus attains the entire impression which is so satisfactory to it. 813. Simple, therefore, as these strictly harmonious contrasts are, as presented to us in the narrow circle, the hint is important, that nature tends to emancipate the sense from confined impressions by suggesting and producing the whole, and that in this instance we have a natural phenomenon immediately applicable to aesthetic purposes. 814. While, therefore, we may assert that the chromatic scale, as given by us, produces an agreeable impression by its ingredient hues, we may here remark that those have been mistaken who have hitherto adduced the rainbow as an example of the entire scale, for the chief color, pure red, is deficient in it, and cannot be produced, since in this phenomenon, as well as in the ordinary prismatic series, the yellow red and blue red cannot attain to a union. 815. Nature perhaps exhibits no general phenomenon where the scale is in complete combination. By artificial experiments such an appearance may be produced in its perfect splendor. The mode, however, in which the entire series is connected in a circle is rendered most intelligible by tints on paper, till after much experience and practice, aided by due susceptibility of the organ, we become penetrated with the idea of this harmony, and feel it present in our minds. 816. Besides these pure, harmonious, self-developed combinations, which always carry the conditions of completeness with them, there are others which may be arbitrarily produced, and which may be most easily described by observing that they are to be found in the colorific circle, not by diameters, but by chords, in such a manner that an intermediate color is passed over. 817. We call these combinations characteristic, because they have all a certain significancy, and tend to excite a definite impression, an impression, however, which does not altogether satisfy, inasmuch as every characteristic quality of necessity presents itself only as a part of a whole, with which it has a relation, but into which it cannot be resolved. 818. As we are acquainted with the impressions produced by the colors singly as well as in their harmonious relations, we may at once conclude that the character of the arbitrary combinations will be very different from each other as regards their significancy. We proceed to review them separately. Yellow and blue. 819. This is the simplest of such combinations. It may be said that it contains too little, for since every trace of red is wanting in it, it is defective as compared with the whole scale. In this view it may be called poor, and as the two contrasting elements are in their lowest state, may be said to be ordinary. Yet it is recommended by its proximity to green, in short, by containing the ingredients of an ultimate state. Yellow and red. 820. This is a somewhat preponderating combination, but it has a serene and magnificent effect. The two extremes of the active side are seen together without conveying any idea of progression from one to the other. As the result of their combination in pigments is yellow-red, so they, in some degree, represent this color. Blue and red. 821. The two ends of the passive side, with the excess of the upper end of the active side. The effect of this juxtaposition approaches that of the blue-red produced by their union. Yellow-red and blue-red. 822. These, when placed together, as the deepened extremes of both sides, have something exciting, elevated. They give us a presentiment of red, which in physical experiments is produced by their union. 823. These four combinations have also the common quality of producing the intermediate color of our colorific circle by their union, a union which actually takes place if they are opposed to each other in small quantities and seen from a distance. A surface covered with narrow blue and yellow stripes appears green at a certain distance. 824. If, again, the eye sees blue and yellow next each other, it finds itself in a peculiar disposition to produce green without accomplishing it, while it neither experiences a satisfactory sensation in contemplating the detached colors, nor an impression of completeness in the two. 825. Thus it will be seen that it was not without reason we called these combinations characteristic, the more so since the character of each combination must have a relation to that of the single colors of which it consists. Combinations non-characteristic. 826. We now turn our attention to the last kind of combinations. These are easily found in the circle. They are indicated by shorter chords, for in this case we do not pass over an entire intermediate color, but only the transition from one to the other. 827. These combinations may justly be called non-characteristic, inasmuch as the colors are too nearly alike for their impression to be significant. Yet most of these recommend themselves to a certain degree, since they indicate a progressive state, though its relations can hardly be appreciable. 828. Thus yellow and yellow-red, yellow-red and red, blue and blue-red, blue-red and red, represent the nearest degrees of augmentation and culmination, and in certain relations as to quantity may produce no unpleasant effect. 829. The juxtaposition of yellow and green has always something ordinary, but in a cheerful sense. Blue and green, on the other hand, is ordinary in a repulsive sense. Our good forefathers called these last fool's colors. Relation of the combinations to light and dark. 830. These combinations may be very much varied by making both colors light or both dark, or one light and the other dark, in which modifications, however, all that has been found true in a general sense is applicable to each particular case. With regard to the infinite variety thus produced, we merely observe 831. The colors of the active side placed next to black gain in energy, those of the passive side lose. The active conjoined with white and brightness lose in strength, the passive gain in cheerfulness. Red and green with black appear dark and grave, with white they appear gay. 832. To this we may add that all colors may be more or less broken or neutralized, may to a certain degree be rendered nameless, and thus combined partly together and partly with pure colors. But although the relations may thus be varied to infinity, still all that is applicable with regard to the pure colors will be applicable in these cases. Considerations derived from the evidence of experience and history. 833. The principles of the harmony of colors having been thus far defined, it may not be irrelevant to review what has been adduced in connection with experience and historical examples. 834. The principles in question have been derived from the constitution of our nature and the constant relations which are found to obtain in chromatic phenomena. In experience we find much that is in conformity with these principles, and much that is opposed to them. 835. Men in a state of nature, uncivilized nations, children, have a great fondness for colors in their utmost brightness, and especially for yellow-red. They are also pleased with the motley. By this expression we understand the juxtaposition of vivid colors without an harmonious balance. But if this balance is observed, through instinct or accident, an agreeable effect may be produced. I remember a Hessian officer returned from America, who had painted his face with the positive colors in the manner of the Indians. A kind of completeness or due balance was thus produced, the effect of which was not disagreeable. 836. The inhabitants of the south of Europe make use of very brilliant colors for their dresses. The circumstance of their procuring silk stuffs at a cheap rate is favorable to this propensity. The women especially, with their bright-colored bodices and ribbons, are always in harmony with the scenery, since they cannot possibly surpass the splendor of the sky and landscape. 837. The history of dyeing teaches us that certain technical conveniences and advantages have had great influence on the costume of nations. We find that the Germans wear blue very generally because it is a permanent color in cloth. So in many districts all the country people wear green twill, because that material takes a green dye well. If a traveler were to pay attention to these circumstances, he might collect some amusing and curious facts. 838. Colors, as connected with particular frames of mind, are again a consequence of peculiar character and circumstances. Lively nations, the French for instance, love intense colors, especially on the active side. Sedate nations, like the English and Germans, wear straw-colored or leather-colored yellow accompanied with dark blue. Nations aiming at dignity of appearance, the Spaniards and Italians, for instance, suffer the red color of their mantles to incline to the passive side. 839. In dress we associate the character of the color with the character of the person. We may thus observe the relation of colors singly and in combination to the color of the complexion, age, and station. 840. The female sex in youth is attached to rose color and sea green, in age to violet and dark green. The fair-haired prefer violet as opposed to light yellow, the brunettes blue as opposed to yellow-red, and on all good grounds. The Roman emperors were extremely jealous with regard to their purple. The robe of the Chinese emperor is orange embroidered with red, his attendants and the ministers of religion wear citron yellow. 841. People of refinement have a disinclination to colors. This may be owing partly to weakness of sight, partly to the uncertainty of taste, which readily takes refuge in absolute negation. Women now appear almost universally in white and men in black. 842. An observation, very generally applicable, may not be out of place here, namely that man, desirous as he is of being distinguished, is quite as willing to be lost among his fellows. 843. Black was intended to remind the Venetian noblemen of republican equality. 844. To what degree the cloudy sky of northern climates may have gradually banished color may also admit of explanation. 845. The scale of positive colors is obviously soon exhausted. On the other hand, the neutral, subdued, so-called fashionable colors present infinitely varying degrees and shades, most of which are not unpleasing. 846. It is also to be remarked that ladies, in wearing positive colors, are in danger of making a complexion which may not be very bright still less so, and thus to preserve a due balance with such brilliant accompaniments, they are induced to heighten their complexions artificially. 847. An amusing inquiry might be made which would lead to a critique of uniforms, liveries, cockades, and other distinctions, according to the principles above hinted at. It might be observed, generally, that such dresses and insignia should not be composed of harmonious colors. Uniforms should be characteristic and dignified. Liveries might be ordinary and striking to the eye. Examples both good and bad would not be wanting, since the scale of colors usually employed for such purposes is limited, and its varieties have been often enough tried. End of section 39. Section 40 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Availle in March 2017. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 40. Aesthetic Influence. 848. From the moral associations connected with the appearance of colors, single or combined, their aesthetic influence may now be deduced for the artist. We shall touch the most essential points to be attended to, after first considering the general condition of pictorial representation, light and shade, with which the appearance of color is immediately connected. Chiaro-Scuro. 849. We apply the term Chiaro-Scuro, hell-dunkel, to the appearance of material objects when the mere effect produced on them by light and shade is considered. 850. In a narrower sense, a mass of shadow lighted by reflexes is often thus designated, but we here use the expression in its first and more general sense. 851. The separation of light and dark from all appearance of color is possible and necessary. The artist will solve the mystery of imitation sooner by first considering light and dark independently of color, and making himself acquainted with it in its whole extent. 852. Chiaro-Scuro exhibits the substance as substance, inasmuch as light and shade inform us as to degrees of density. 853. We have here to consider the highest light, the middle tint, and the shadow, and in the last the shadow of the object itself, the shadow it casts on other objects, and the illuminated shadow or reflection. 851. The globe is well adapted for the general exemplification of the nature of Chiaro-Scuro, but it is not altogether sufficient. The softened unity of such complete rotundity tends to the vapory, and in order to serve as a principle for effects of art, it should be composed of plane surfaces, so as to define the gradations more. 855. The Italians call this manner il piazzoso. In German it might be called das Flächenhafte. If, therefore, the sphere is a perfect example of natural Chiaro-Scuro, a polygon would exhibit the artist-like treatment in which all kinds of lights, half-lights, shadows, and reflections would be appreciable. 856. The bunch of grapes is recognized as a good example of a picturesque completeness in Chiaro-Scuro, the more so as it is fitted, from its form, to represent a principal group, but it is only available for the master who can see in it what he has the power of producing. 857. In order to make the first idea intelligible to the beginner, for it is difficult to consider it abstractedly even in a polygon, we may take a cube, the three sides of which that are seen represent the light, the middle tint, and the shadow in distinct order. 858. To proceed again to the Chiaro-Scuro of a more complicated figure, we might select the example of an open book, which presents a greater diversity. 859. We find the antique statues of the best time treated very much with reference to these effects. The parts intended to receive the light are wrought with simplicity. The portion originally in shade is, on the other hand, in more distinct surfaces to make them susceptible of a variety of reflections. Here the example of the polygon will be remembered. 860. The pictures of Herculaneum and the Aldobrandini marriage are examples of antique painting in the same style. 861. Modern examples may be found in single figures by Raphael, in entire works by Correggio, and also by the Flemish masters, especially Rubens. Tendency to color. 862. A picture in black and white seldom makes its appearance. Some works of Polidoro are examples of this kind of art. Such works, inasmuch as they can attain form and keeping, are estimable, but they have little attraction for the eye, since their very existence supposes a violent abstraction. 863. If the artist abandons himself to his feeling, color presently announces itself. Black no sooner inclines to blue than the eye demands yellow, which the artist instinctively modifies and introduces partly pure in the light, partly reddened and subdued as brown in the reflexes, thus enlivening the whole. 864. All kinds of camailleux, or color on similar color, end in the introduction either of a complemental contrast or some variety of hue. Thus, Polidoro in his black and white frescoes sometimes introduced a yellow vase or something of the kind. 865. In general, it may be observed that men have at all times instinctively striven after color in the practice of the art. We need only observe daily how soon amateurs proceed from colorless to colored materials. Paolo Uccello painted colored landscapes to colorless figures. 866. Even the sculpture of the ancients could not be exempt from the influence of this propensity. The Egyptians painted their bas-reliefs. Statues had eyes of colored stones. Porphyry draperies were added to marble heads and extremities, and variegated stalactites were used for the pedestals of busts. The Jesuits did not fail to compose the statue of their Saint Luigi in Rome in this manner, and the most modern sculpture distinguishes the flesh from the drapery by staining the latter. Keeping. 867. If linear perspective displays the gradation of objects in their apparent size as affected by distance, aerial perspective shows us their gradation in greater or less distinctness, as affected by the same cause. 868. Although from the nature of the organ of sight we cannot see distant objects so distinctly as nearer ones, yet aerial perspective is grounded strictly on the important fact that all mediums called transparent are in some degree dim. 869. The atmosphere is thus always, more or less, semi-transparent. This quality is remarkable in southern climates, even when the barometer is high, the weather dry, and the sky cloudless, for a very pronounced gradation is observable between objects but little removed from each other. 870. The appearance on a large scale is known to everyone. The painter, however, sees or believes he sees the gradation in the slightest varieties of distance. He exemplifies it practically by making a distinction, for instance, in the features of a face according to their relative position as regards the plane of the picture. The direction of the light is attended to in like manner. This is considered to produce a gradation from side to side, while keeping has reference to depth, to the comparative distinctness of near and distant things. 871. In proceeding to consider this subject, we assume that the painter is generally acquainted with our sketch of the theory of colors, and that he has made himself well acquainted with certain chapters and rubrics which especially concern him. He will thus be enabled to make use of theory as well as practice in recognizing the principles of effect in nature, and in employing the means of art. Color in general nature. 872. The first indication of color announces itself in nature together with the gradations of aerial perspective, for aerial perspective is intimately connected with the doctrine of semi-transparent mediums. We see the sky, distant objects, and even comparatively near shadows, blue. At the same moment, the illuminating and illuminated objects appear yellow, gradually deepening to red. In many cases, the physiological suggestion of contrasts comes into the account, and an entirely colorless landscape, by means of these assisting and counteracting tendencies, appears to our eyes completely colored. 873. Local colors are composed of the general elementary colors, but these are determined or specified according to the properties of substances and surfaces on which they appear. This specification is infinite. 874. Thus, there is at once a great difference between silk and wool similarly dyed. Every kind of preparation and texture produces corresponding modifications. Roughness, smoothness, polish, all are to be considered. 875. It is therefore one of the pernicious prejudices of art that the skilful painter must never attend to the material of draperies, but always represent, as it were, only abstract folds. Is not all characteristic variety thus done away with, and is the portrait of Leo X less excellent because velvet, satin, and moreen are imitated in their relative effect? 876. In the productions of nature, colors appear more or less modified, specified, even individualized. This may be readily observed in minerals and plants, in the feathers of birds and the skins of beasts. 877. The chief art of the painter is always to imitate the actual appearance of the definite hue, doing away with the recollection of the elementary ingredients of color. This difficulty is in no instance greater than the imitation of the surface of the human figure. 878. The color of flesh as a whole belongs to the active side, yet the bluish of the passive side mingles with it. The color is altogether removed from the elementary state and neutralized by organization. 879. To bring the coloring of general nature into harmony with the coloring of a given object will perhaps be more attainable for the judicious artist after the consideration of what has been pointed out in the foregoing theory. For the most fancifully beautiful and varied appearances may still be made true to the principles of nature. Characteristic coloring. 880. The combination of colored objects, as well as the color of their ground, should depend on considerations which the artist pre-establishes for himself. Here a reference to the effect of colors, singly or combined, on the feelings is especially necessary. On this account the painter should possess himself with the idea of the general dualism, as well as of particular contrasts, not forgetting what has been adverted to with regard to the qualities of colors. 881. The characteristic in color may be comprehended under three leading rubrics, which we here define as the powerful, the soft, and the splendid. 882. The first is produced by the preponderance of the active side, the second by that of the passive side, and the third by completeness, by the exhibition of the whole chromatic scale in due balance. 883. The powerful impression is attained by yellow, yellow-red, and red, which last color is to be arrested on the plus side. But little violet and blue, still less green, are admissible. The soft effect is produced by blue, violet, and red, which in this case is arrested on the minus side. A moderate addition of yellow and yellow-red, but much green may be admitted. 884. If it is proposed to produce both these effects in their full significancy, the complemental colors may be excluded to a minimum, and only so much of them may be suffered to appear as is indispensable to convey an impression of completeness. End of section 40. Section 41 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Availle in March 2017. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 41. Harmonious coloring. 885. Although the two characteristic divisions as above defined may in some sense be also called harmonious, the harmonious effect, properly so called, only takes place when all the colors are exhibited together in due balance. 886. In this way, the splendid as well as the agreeable may be produced. Both of these, however, have of necessity a certain generalized effect, and in this sense may be considered the reverse of the characteristic. 887. This is the reason why the coloring of most modern painters is without character, for, while they follow their general instinctive feeling only, the last result of such a tendency must be mere completeness. This they more or less attain, but thus at the same time neglect the characteristic impression which the subject may demand. 888. But if the principles before alluded to are kept in view, it must be apparent that a distinct style of color may be adopted on safe grounds for every subject. The application requires, it is true, infinite modifications, which can only succeed in the hands of genius. Genuine tone. 889. If the word tone, or rather tune, is to be still borrowed in future from music and applied to coloring, it might be used in a better sense than heretofore. 890. For it would not be unreasonable to compare a painting of powerful effect with a piece of music in a sharp key, a painting of soft effect with a piece of music in a flat key, while other equivalents might be found for the modifications of these two leading modes. False tone. 891. The word tone has been hitherto understood to mean a veil of a particular color spread over the whole picture. It was generally yellow, for the painter instinctively pushed the effect towards the powerful side. 892. If we look at a picture through a yellow glass, it will appear in this tone. It is worthwhile to make this experiment again and again, in order to observe what takes place in such an operation. It is a sort of artificial light, deepening and at the same time darkening the plus side and neutralizing the minus side. 893. This spurious tone is produced instinctively through uncertainty as to the means of attaining a genuine effect, so that instead of completeness, monotony is the result. Weak coloring. 894. It is owing to the same uncertainty that the colors are sometimes so much broken as to have the effect of the grey camailleux, the handling being at the same time as delicate as possible. 895. The harmonious contrasts are often found to be very happily felt in such pictures, but without spirit, owing to a dread of the motley. The motley. 896. A picture may easily become partly colored or motley when the colors are placed next each other in their full force, as it were only mechanically and according to uncertain impressions. 897. If, on the other hand, weak colors are combined, even although they may be dissonant, the effect, as a matter of course, is not striking. The uncertainty of the artist is communicated to the spectator, who, on his side, can neither praise nor censure. 898. It is also important to observe that the colors may be disposed rightly in themselves, but that a work may still appear motley if they are falsely arranged in relation to light and shade. 899. This may the more easily occur as light and shade are already defined in the drawing, and are, as it were, comprehended in it, while the color still remains open to selection. Dread of theory. 900. A dread of, nay, a decided aversion for all theoretical views respecting color and everything belonging to it has been hitherto found to exist among painters, a prejudice for which, after all, they were not to be blamed, for what has been hitherto called theory was groundless, vacillating, and akin to empiricism. We hope that our labors may tend to diminish this prejudice, and stimulate the artist practically to prove and embody the principles that have been explained. Ultimate aim. 901. But without a comprehensive view of the whole of our theory, the ultimate object will not be attained. Let the artist penetrate himself with all that we have stated. It is only by means of harmonious relations in light and shade, in keeping, in true and characteristic coloring, that a picture can be considered complete, in the sense we have now learned to attach to the term. Grounds. 902. It was the practice of the earlier artists to paint on light grounds. This ground consisted of gypsum and was thickly spread on linen or panel, and then levigated. After the outline was drawn, the subject was washed in with a blackish or brownish color. Pictures prepared in this manner for coloring are still in existence, by Leonardo da Vinci and Fra Bartolomeo. There are also several by Guido. 903. When the artist proceeded to color and had to represent white draperies, he sometimes suffered the ground to remain untouched. Titian did this latterly when he had attained the greatest certainty in practice and could accomplish much with little labor. The whitish ground was left as a middle tint, the shadows painted in, and the highlights touched on. 904. In the process of coloring, the preparation merely washed, as it were, underneath, was always effective. A drapery, for example, was painted with a transparent color. The white ground shone through it and gave the color life, so the parts previously prepared for shadows exhibited the color subdued, without being mixed or sullied. 905. This method had many advantages, for the painter had a light ground for the light portions of his work, and a dark ground for the shadowed portions. The whole picture was prepared, the artist could work with thin colors in the shadows, and had always an internal light to give value to his tints. In our own time, painting in watercolors depends on the same principles. 906. Indeed, a light ground is now generally employed in oil painting, because middle tints are thus found to be more transparent, and are in some degrees enlivened by a bright ground. The shadows, again, do not so easily become black. 907. It was the practice for a time to paint on dark grounds. Tintoret probably introduced them. Titian's best pictures are not painted on a dark ground. 908. The ground in question was red-brown, and when the subject was drawn upon it, the strongest shadows were laid in, the colors of the lights impasted very thickly in the bright parts, and scumbled towards the shadows, so that the dark ground appeared through the thin color as a middle tint. Effect was attained in finishing by frequently going over the bright parts and touching on the highlights. 909. If this method especially recommended itself in practice on account of the rapidity it allowed of, yet it had pernicious consequences. The strong ground increased and became darker, and the light colors losing their brightness by degrees, gave the shadowed portions more and more preponderance. The middle tints became darker and darker, and the shadows at last quite obscure. The strongly impasted lights alone remained bright, and we now see only light spots on the painting. The pictures of the Bolognese school and of Caravaggio afford sufficient examples of these results. 910. We may here in conclusion observe that glazing derives its effect from treating the prepared color underneath as a light ground. By this operation, colors may have the effect of being mixed to the eye, may be enhanced, and may acquire what is called tone, but they thus necessarily become darker. Pigments. 911. We receive these from the hands of the chemist and the investigator of nature. Much has been recorded respecting coloring substances, which is familiar to all by means of the press. But such directions require to be revised from time to time. The master meanwhile communicates his experience in these matters to his scholar, and artists generally to each other. Those pigments which according to their nature are the most permanent are naturally much sought after, but the mode of employing them also contributes much to the duration of a picture. The fewest possible coloring materials are to be employed, and the simplest methods of using them cannot be sufficiently recommended. 913. For from the multitude of pigments coloring has suffered much. Every pigment has its peculiar nature as regards its effect on the eye. Besides this, it has its peculiar quality, requiring a corresponding technical method in its application. The former circumstance is a reason why harmony is more difficult of attainment with many materials than with few. The latter, why chemical action and reaction may take place among the coloring substances. 914. We may refer, besides, to some false tendencies which the artists suffer themselves to be led away with. Painters are always looking for new coloring substances, and believe, when such a substance is discovered, that they have made an advance in the art. They have a great curiosity to know the practical methods of the old masters, and lose much time in the search. Towards the end of the last century, we were thus long tormented with wax painting. Others turn their attention to the discovery of new methods, through which nothing new is accomplished, for, after all, it is the feeling of the artist only that informs every kind of technical process. End of section 41. Section 42 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Availle in March 2017. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 42. Allegorical, symbolical, mystical application of color. 915. It has been circumstantially shown above that every color produces a distinct impression on the mind, and thus addresses at once the eye and feelings. Hence it follows that color may be employed for certain moral and aesthetic ends. 916. Such an application, coinciding entirely with nature, might be called symbolical, since the color would be employed in conformity with its effect, and would at once express its meaning. If, for example, pure red were assumed to designate majesty, there can be no doubt that this would be admitted to be a just and expressive symbol. All this has been already sufficiently entered into. 917. Another application is nearly allied to this. It might be called the allegorical application. In this there is more of accident and caprice, inasmuch as the meaning of the sign must be first communicated to us before we know what it is to signify. What idea, for instance, is attached to the green color, which has been appropriated to hope? 918. That, lastly, color may have a mystical allusion may be readily surmised, for since every diagram in which the variety of colors may be represented points to those primordial relations which belong both to nature and the organ of vision, there can be no doubt that these may be made use of as a language, in cases where it is proposed to express similar primordial relations which do not present themselves to the senses in so powerful and varied a manner. The mathematician extols the value and applicability of the triangle. The triangle is revered by the mystic. Much admits of being expressed in it by diagrams, and, among other things, the law of the phenomena of colors. In this case, indeed, we presently arrive at the ancient mysterious hexagon. 919. When the distinction of yellow and blue is duly comprehended, and especially the augmentation into red, by means of which the opposite qualities tend towards each other and become united in a third, then, certainly, an especially mysterious interpretation will suggest itself, since a spiritual meaning may be connected with these facts. And when we find the two separate principles producing green on the one hand and red in the intenser state, we can hardly refrain from thinking in the first case on the earthly, in the last on the heavenly generation of the Elohim. 920. but we shall do better not to expose ourselves, in conclusion, to the suspicion of enthusiasm, since, if our doctrine of colours finds favour, applications and allusions, allegorical, symbolical, and mystical, will not fail to be made, in conformity with the spirit of the age. Concluding observations. In reviewing this labour, which has occupied me long, and which at last I give but as a sketch, I am reminded of a wish once expressed by a careful writer, who observed that he would gladly see his works printed at once as he conceived them, in order then to go to the task with a fresh eye, since everything defected presents itself to us more obviously in print than even in the cleanest manuscript. This feeling may be imagined to be stronger in my case, since I had not even an opportunity of going through a fair transcript of my work before its publication, these pages having been put together at a time when a quiet, collected state of mind was out of the question. Some of the explanations I was desirous of giving are to be found in the introduction, but in the portion of my work to be devoted to the history of the doctrine of colours, I hope to give a more detailed account of my investigations and the vicissitudes they underwent. One inquiry, however, may not be out of place here, the consideration, namely, of the question, what can a man accomplish who cannot devote his whole life to scientific pursuits? What can he perform as a temporary guest on an estate not his own, for the advantage of the proprietor? When we consider art in its higher character, we might wish that masters only had to do with it, that scholars should be trained by the severest study, that amateurs might feel themselves happy in reverentially approaching its precincts. For a work of art should be the effusion of genius, the artist should evoke its substance and form from his inmost being, treat his materials with sovereign command, and make use of external influences only to accomplish his powers. But if the professor in this case has many reasons for respecting the dilettante, the man of science has every motive to be still more indulgent, since the amateur here is capable of contributing what may be satisfactory and useful. The sciences depend much more on experiment than art, and for mere experiment many a votary is qualified. Scientific results are arrived at by many means, and cannot dispense with many hands, many heads. Science may be communicated, the treasury may be inherited, and what is acquired by one may be appropriated by many. Hence, no one, perhaps, ought to be reluctant to offer his contributions. How much do we not owe to accident, to mere practice, to momentary observation? All who are endowed only with habits of attention, women, children, are capable of communicating striking and true remarks. In science it cannot therefore be required that he who endeavours to furnish something in its aid should devote his whole life to it, should survey and investigate it in all its extent, for this, in most cases, would be a severe condition even for the initiated. But if we look through the history of science in general, especially the history of physics, we shall find that many important acquisitions have been made by single inquirers, in single departments, and very often by unprofessional observers. To whatever direction a man may be determined by inclination or accident, whatever class of phenomena especially strike him, excite his interest, fix his attention, and occupy him, the result will still be for the advantage of science, for every new relation that comes to light, every new mode of investigation, even the imperfect attempt, even error itself, is available. It may stimulate other observers, and is never without its use as influencing future inquiry. With this feeling the author himself may look back without regret on his endeavours. From this consideration he can derive some encouragement for the prosecution of the remainder of his task, and although not satisfied with the result of his efforts, yet reassured by the sincerity of his intentions, he ventures to recommend his past and future labours to the interest of his contemporaries and posterity. multi per transibunt et augebitur scientia. End of section 42. End of Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake.